Alright, this is the Why Atom Combined notes, and we are going to be talking and taking notes on why the different atoms combine. We have talked over the last few weeks about elements, compounds, and mixtures. We're now going to go back and add in the scientific reasoning for why elements become compounds. So, as you can see, when atoms combine, they form compounds. That should be a review. We know that they form from chemical reactions, not physical, but chemical reactions. Right? You can see a couple common compounds down there in the corner. We also know that compounds have properties unlike the elements that make them up. Also, again, review. And the example we always talk about, water, hydrogen and oxygen, which are two gases at room temperature, chemically combine to form a liquid. So while hydrogen and oxygen by themselves are gases, when they combine together, we know water is a liquid at room temperature. Alright, so compounds, two or more elements chemically combined. They're formed in chemical reactions. They also have properties different from their components. This should all be reviewed from vocab. Okay, now we're moving on to the new stuff. Alright, so what's a chemical formula? When we have a compound, and you've already seen chemical formulas such as H2O, but what is it? What's it technically defined as? A formula is a combination of chemical symbols that represent elements that have joined together. Sometimes we know that there's also what's called a subscript number. Subscript means written below, so that's why they have assigned that name. And a subscript number tells how many atoms of the element there are in a molecule. Okay. We also know that if there is no subscript at all, that means there is one atom of the molecule. We'll do an example of that in a minute. So if you see a subscript, it tells you how many atoms of that element there are. And if there's no subscript, only an element, then there's just one. All right, so a couple examples for you. Fe2O3. In this ratio, the ratio of Fe to O is 2 to 3, which tells me that there are 2 atoms of iron, or Fe, for every 3 atoms of oxygen, or O. Okay, so Fe2,3, the ratio 2 to 3, as you can see. And another example, H2O. As you can see, the ratio is 2 to 1, and there are 2 atoms of hydrogen for every 1 atom of oxygen. There is no subscript, which means that there must just be 1 atom of oxygen. So, 2 atoms of hydrogen and just 1 atom of oxygen. Okay. So chemically stable atoms. We've talked about atoms that want to bond versus atoms that are unstable, are stable and don't want to bond. So what does that mean? What is it explaining when we say chemically stable atoms? Well, the arrangement of electrons in the outer level, the very outer level, also known as the valence electrons. We're going back to the periodic table here. The valence electrons determine how stable an atom will be. If an atom doesn't have all the valence electrons it wants, then it wants to bond with something. It's not stable. Whereas an atom who has a full valence shell, or all the valence electrons it wants, is going to be stable. It's not going to react with anything. All right? So we assign this rule called the octet rule. And the octet rule states that every atom wants to have 8 electrons in the outer level. It will either give up extras or take on extras as long as it gets 8 in the outer level. Okay, so that's what we would call a full, happy outer shell. When an atom has 8, it is considered stable. Okay, so just a little refresher. This isn't in your notes. You don't need to write this down. But if you remember, how do we find valence electrons? If you look here, we use the group number. If you look, group 1 has 1 valence electron, group 2 has 2, and then we skip over to 13. Remember, this right here is group 13, and we know if it's group 13, we drop the 1, and we get 3 valence electrons, all the way 14, 15, 16, 17, 18, with one exception to that rule. So, group number is how we find the valence electrons, or column number. If it's double digits, drop the 1, and the only exception, helium. All right, so you should not have written any of that down. That was just a little refresher. We'll go back to the notes now. So which family on the periodic table is stable? Which one is already happy? We know it's group 18. Anybody remember the name? The noble gases. The noble gases are stable. They're already happy. So because they have 8 valence electrons, they're already stable. They do not need to combine with other atoms. They often just hang out by themselves. All right, moving to the next section, which is the chemical bonding section. So we've talked about if it's stable, it doesn't want to bond. If it's unstable, if it wants more valence electrons, then it is going to bond. So what does that look like? How do they bond? Well, atoms form chemical bonds in order to become stable. So if they're unstable, then that's what they're working towards. They want to be like the noble gases. They're jealous. So they accomplish this by losing, gaining, or sharing electrons. And we're going to talk about the different circumstances for each. So there are 2 main types of bonds we're going to talk about. And the first is what we call an ionic bond. An ionic bond is a bond between 2 atoms that transfer electrons. It is a bond between a metal and a non-metal. So when you're looking at your periodic table, you can tell what bond is going to be taking place based on whether these elements are metals or non-metals. So this is a bond between a metal and a non-metal. And it creates what we call ions. We know ions is that word simply means charged atoms. It has a charge, a positive or a negative, and it causes ions to be formed. So we're going to go back and highlight here. Skipped a couple of words. Alright, so if we're looking at ionic bonds is where the electron from one is transferred to another. So let's talk about the example sodium chloride. We know sodium chloride, the chemical formula is Na, 1 atom of Na, and 1 atom of Cl. So 1 atom of sodium, 1 atom of chlorine bond to make NaCl, which is actually salt. Sorry about my handwriting. Alright, so if we look here, if we look at Na, we find it on the periodic table. You can see it's in group 1, which tells me it has 1 valence electron. Alright, so we're going to write 1 valence electron. Alright, if you look at the periodic table, you can see chlorine is in group 17. We drop that 1, it tells me I have 7 valence electrons. Alright, so let's count them. 1, 2, 3, 4, 5, 6, 7. Alright, how many did we say was happy? We said 8. We said the octet rule tells me that every atom wants 8. So sodium has 1, chlorine has 7. What ends up happening is sodium says, here, I have 1 extra. If I get rid of it, I go back to my other valence, which is full. Take one of mine, I'll become stable, you'll become stable, and we're all happy. So Na hands one of its valence electrons over to chlorine. Chlorine takes it on, and both of them end up with 8. And as you can see, sodium ends up with 0 in that outer shell, which makes the actual outer shell kind of disappear, leaving 8 on the inside one. All right, so now we're both happy, the octet rule. What happens in this case, if sodium loses an electron, electrons are negatively charged. If it loses one of its negatives, all of a sudden it is no longer neutrally charged. In fact, Na is going to become positively charged. It lost a negative. Meanwhile, chlorine takes on an extra electron. Electrons are negative, so it is going to have a negative charge. So the positive and the negative attract, and because they attract, those two are bonded. Even though they're not actually sharing electrons, they're bonded because of their charges, and they kind of stick together. So if you look down here, electron from Na is transferred to Cl. This causes a charge imbalance in each atom. The Na becomes positive and the Cl becomes negative. Charged particles or ions, we know that opposite charges do what? They attract. All right. We're going to do more practice, so if that didn't make sense, don't freak out. Okay, I'm going to go back a slide. Just remember, ionic bonds are between a metal and a nonmetal. When you see a metal and a nonmetal bonding, you know one is going to be giving away to the other. All right, covalent bond is the other type. A covalent bond is the attractive or the attraction that forms between atoms when they share electrons. This is a bond between two nonmetals. All right. And this happens when they share electrons. We know covalent bonding, they're sharing electrons, and it's between two nonmetals. So you can see this looks a little different. One's not handing the other one an electron. Instead, they're sharing electrons. So let's look at an example of that. We're going to go back to water, our normal. Okay, so we know in this case we are sharing electrons, hydrogen and oxygen, both nonmetals. All right, we have oxygen, if we look at the periodic table, is in group 16, gives me 6 valence electrons. Hydrogen, group 1, each one of these has 1 valence electron. All right, so hydrogen, and oxygen, they're hanging out in the same room and they decide to cut a deal. Oxygen's like, listen, I've got 6, I need 2. Each of you has 1. If you each share 1 and I share 1 with you, then we're all going to end up happy. Okay, so oxygen has 1, 2, 3, 4. It's sharing 1 with this hydrogen, and it's sharing 1 with this hydrogen. That's its original 6. Meanwhile, hydrogen, it's sharing its 1 with oxygen, and this one is also sharing 1 with oxygen. That gives every hydrogen 2. We know the first ring is happy with 2. So that is satisfying the octet rule even without the 8. Meanwhile, oxygen now has its 8. We're all happy. Yay. And we're moving on. So, covalent sharing. When you collaborate, when you are working together, you are collabing. It is a covalent bond. You share. I am selfish. Ionic bonds are between a metal and a nonmetal. One steals from the other. That's my way to remember it. Okay. All right. We are going to do practice in the next video.